Hello. I'm MC Toon. Sorry. Everything happened at the same time. The worst rapper in the world. And my microphone's going crazy. There we go. Nope. Still going crazy. Wow. How's that? Got some loop back. So, welcome everybody to the big live stream. We are having an interesting one, a little different than usual today. It is a discussion on whether or not angular momentum is conserved. This is between Jack Zong and John, and I don't want to say his last name wrong, but let me pop in Jack first because we're still waiting for John. How you doing?
I'm all right. Just tired.
Tired. All right. People can see you and hear you.
Woohoo!
So,
Very excited.
but let's see. What's his last name? So I get it right.
He's South African. I have no idea what that's supposed to be. Mandelbar or
Sounds
well,
good.
we'll let him introduce himself when he gets.
Yeah. So I sent him the link, and I think he's got it. Maybe not. We don't know. We'll see. But a little something here, Jack. Do you know it's Magda's birthday?
Whose birthday?
Magda. You could just say happy birthday to Magda. She's in the live chat.
Happy birthday, Magda.
There you go. Let's see. I've got a couple things. If you were following along last week, I was trying to have a interview with the guy, the main author for the paper on that claimed that 5G can have a two-way communication with DNA and then cause DNA to generate coronavirus RNA. Anyway, it didn't happen last week. We're going to try again next week for him and his second author. We'll see. They're Italian, so their English is a little rough. So, what do you think about that, Jack? Would that be interesting?
That would be interesting. We're starting to review papers now. We've moved on from the low-hanging fruit.
Yeah.
Now
They asked today in an email about having a film crew and that they're going to have a film crew for some documentary that I don't know. I'm like, no film crew. Let's see. All the people who do hammer throw as a sport will be very surprised if it turns out angular momentum isn't conserved. That's a good point there, Microraptor. The figure skaters will be sad to know too that they can no longer figure skate and do their circly things. So, but I guess if it's disproved, it's disproved. We can't argue it if it's so. And later tonight, all right. So later tonight, I've got a debate with Avery. Something.
Oh, he's here.
There he is. I'll have to fix that. Avery Walters, I have a debate. He thinks the Earth is flat. Silly guy. So, all right, I'm going to fix the video here so that everybody can see everybody just fine. How you doing there, John? People can hear you.
Hi. Can you hear me now?
Yes.
Okay. All right.
How do we say your last name? Because we have no.
Mandelbaum.
Okay, Mandelbaum.
Okay. Well, that's how we guessed it. Good.
Okay. Excellent.
All right, I'm almost ready. They can't quite see you correctly, and now they can. There we go. So,
Okay.
John, I have you have a paper. I think I found the right paper, and so I can put it on screen, or you can present using Zoom, just so you know. But let's do this, John. Why don't you introduce yourself before you get into anything? Just whatever you want to say about yourself. Go ahead.
All right, great. Okay, well, my name's John Mandelbauer. I'm the owner of a company called Bauer Research, which does research and development of try to bring different products to the market. My successful product is called the E-Clock. It's a time and attendance system. And I have about 300 customers that are using it in and around Joburg at the moment. And that's basically what it's about, and what the discovery that I made, that's my paper is about, I made through doing research and development. Basically, one of the projects that I was working on, one of the approaches that I was working on to a project required me to build models, prototype models, to conserve as much angular momentum as possible. And that's how that's the beginning of how I discovered my discovery.
Okay. So we have a format. Let me just make sure that I have this right so that we all agree. So, John, you're going to present your paper or whatever you have there, and during that time, Jack won't be saying anything. He'll just be muted. I'll mute him, and then
Okay.
when you're done, Jack will have a chance to respond, and then same thing. You won't. Right, you won't say anything. And then once Jack's initial response is done, then it'll just be an open discussion for the rest of the time. And maybe after some amount of discussion, we'll see if there's any questions from the audience, if you want to be around for that part.
Okay. That sounds great to me, yeah. Okay.
So, all right, whenever you're ready.
Okay. All right, okay. All right, well, look, the basic idea of this is my paper, as far as I understand, this is an engineering forum. My paper is basic stuff. It's elementary. There really isn't a whole lot for me to go through over with it. If you've got the paper, you can have a look at it, and that's what it is. Okay. But there are a few things that I do want to make clear let's put it this way. There's a few rules. Okay. Not my rules. These are rules of discussion that people seem to have an issue obeying when they address my paper. Okay, so I just want to go through them. Okay, basically this is one, my paper is a professional quality paper. Okay, what that means is that if I put that paper into any scientific journal, doesn't matter which one, it is going to pass through all of the lower levels of the junior editors and whatever, and it's going to land straight on the desk of the editor-in-chief of the journal. Okay, because there's no errors in the paper. It contains everything it needs to. The formatting is right. The grammar is right. The paper is perfect. So nobody must tell me that my paper is poor, because that's just plain nonsense. Okay, right. Secondly, my paper is a mathematical paper. Okay, now this is not a difficult concept. It's a mathematical proof. If you want to address my paper, then you must point out an equation number and explain the error in the equation, or you must accept the conclusion. That's how mathematical papers work. Okay, so telling me that there's a vague error within somewhere, and that, a omission of something or whatever, that's all nonsense. Okay, address it like a mathematical paper, please. All right. Third thing, reductio ad absurdum. My paper is a reductio ad absurdum. What that means is I take the existing theory out of my physics book as it is, perform the calculations accordingly, come up with a result. Okay, the result is ridiculous. That proves that the equations that I've chosen from my physics book are wrong. Okay, that means that you cannot attack equation 1 or equation 10, because if you're attacking the premise of reductio ad absurdum, then that is completely illogical. All right, so equation 1, equation 10 are out of if you're trying to tell me those are wrong, then you're telling me that my proof that physics is wrong because physics is wrong, not rational. Won't accept it. Okay, right. Next point, friction. Okay. Friction, firstly, this is a theoretical physics paper. So in theoretical physics paper, we don't talk about friction. Friction is considered, you ignore it in a theoretical physics paper, and you expect that if you do the prediction with using the theoretic physics paper without friction, you expect to get a reasonable ballpark prediction of the result. You don't expect a perfect result, fine, but you do expect to get something reasonable, and you can't tell me that friction explains a complete contradiction. Okay, that's a joke. That's out of the question as well. Not something to argue about. Okay. So those are the rules of engagement. And then there's one other thing that I want to discuss, and that's specifically for engineering. Okay. Every single engineer that I've ever presented my paper to comes to me with the same delusional thinking. Okay. No offense. It's just my assessment of what's happening. Okay. So I want to cover this, if I can, just give me a couple of minutes. Okay. So engineers believe that in rotational motion that momentum is conserved, right? And that's absolutely correct. Momentum is conserved in rotational motion, all right? But engineers also believe that they can in conserving the momentum, they are conserving angular momentum simultaneously, okay? And that is simply delusional, okay? And let me explain why. It's going to take 10 seconds because it's very simple. I don't know if I'm going to be able to make this clear. Can I turn the camera around on this thing? I don't know how. All right, I'll just have to do it like this. The original definition for angular momentum, okay? I don't know if you can you see that there? Does that make sense?
Yeah, we can see that.
Okay, L equals R cross P, right? That's not one of the definitions or whatever. That is the original defining one, okay? L equals R cross P. Now, if as an engineer, you conserve the momentum, okay, then if you change the radius, the angular momentum is going to change by definition, okay? And angular momentum cannot possibly change and be conserved simultaneously. Not possible, okay? All right, let's take it a step further and say, all right, the engineers conserve momentum, angular momentum can't be conserved, okay? Physicists, on the other hand, they say angular momentum is conserved, okay? So they're conserving angular momentum, and if that's the case, then if we change the radius, then momentum, and physicists do say this, momentum they don't say magically, but they magically say it magically changes to conserve angular momentum. That's what physicists say, okay? And, the only possible way that the engineers can be right about conserving momentum simultaneously with angular momentum is if you conserve the radius at the same time. Okay, so it's just nonsense. Okay, all right. Does that make sense? All right. Let's go a step further now. So I've got my L equals R cross P on the board, and what I'm going to do is try and explain it like this. As simple as this. This here, the momentum is engineers conserve that. Okay. This here, angular momentum. Okay. The physicists conserve that. Okay. Now, engineers contradict physicists directly, like opposite sides of the equation, direct contradiction. Okay. And where I'm coming in is this, is that I'm saying that my idea of all of this is that the momentum here is what is conserved. The engineers are right. Engineers are right to conserve momentum, and because that supports conservation of angular energy, which is what I'm saying is conserved, and that directly contradicts physicists that say that angular momentum is conserved. Okay, and that's, I think the introduction is good enough. I think we can hand that over to Jack.
All right, hold on. I'll get it back to the right settings here. Just a second. He's muted, so. All right. Jack, you'll have to finish unmuting yourself. Oop. I accidentally muted you, and then we'll swap that, and then Jack can go.
All right. I don't have much to say about that particular preamble. I'm just waiting to get into specific details. We agreed that we would go through his paper page by page, and that's what I'm really waiting for. But I guess just to familiarize the audience, angular momentum is sort of analogous to linear momentum in that it's a conserved quantity. So, for example, in linear mechanics, we say that if some object is moving at some velocity with some mass, then unless it's being acted upon by an external force, that momentum will never change. And similarly with angular momentum, if something is spinning at some particular rate, then that rate of spin will never change unless it's being acted upon by an unbalanced torque. The way we quantize linear momentum is mass times velocity, and for angular momentum, we can either take the cross product between the radial vector and the linear momentum vector, or we can take we take a unit vector that is normal to the to both the radial vector and the linear momentum vector, and we scale that by the the moment of inertia multiplied by its angular velocity in radians per second. But that's really all I have to say. Let's go on to the paper. I'm not, because John said he's new to Zoom, so maybe you can share it because I know you've seen it. So perhaps you can share it on your screen and then we can go through it step by step or something like that. Yeah.
Mm-hmm. Okay. So, well, where do you want to start, Jack?
Start from the beginning. That would be a good place to start.
Well, so the introduction page.
Sure. Here.
Let me skip that and go to the thought experiment.
We can skip the introduction because we just did an introduction. Let's just go to our the meat of the paper, so to speak.
Okay, great. All right. Well, the first page then, so to speak, is the thought experiment. Okay. And what I do there is I basically take the stock standard 300-year-old demonstration of conservation of angular momentum, ball on a string demonstration, as it's conducted in a class, and I calculate the prediction as per physics. Okay. And the result comes to 12,000 RPM, which is roughly the speed of a Ferrari engine. And that is objectively wrong.
Michael, could you just scroll down because I'm watching the stream too, and let's get on the right page here so everyone's on literally on the.
There we go.
Yep. All right. Okay, so you say I would say that most professors would have. Or I'm sorry, are you done, or are you gonna?
Yeah, no, I'm waiting for you. Yeah.
All right.
Go for it.
All right. So he's here. It says that I would say that most professors have, when performing the ball on a string demonstration, find the device at about 2 revolutions per second and then reduce the radius to about 10% of original. That's a very odd format to take this in. Generally speaking, when you want to prove a property, you would never take a specific example unless you're trying to basically show if you want to prove the existence of some particular quantity, then you would just have a test variable. But if you want to show that something's true in general, you would restrict it to just variables. You would never actually stick in any sort of constant like 2 revolutions per second. But we'll run with it for now.
I'm working out the typical demonstration. If I work out the typical demonstration, I have to evaluate it. That's what I mean.
Okay, sure. Personally, I would perform it much faster while optimizing radius reduction. Okay, so I'm not sure what that means, optimizing radius reduction. What are you optimizing here? And how would you define?
What I mean there is, I say, as I've said in the paper, personally, I've performed it much faster while optimizing radius reduction. So my point is, with that statement, is that this setup here is extremely reasonable and repeatable. Okay,
Okay.
because people were telling me, it's two revolutions per second, too fast to start, and the radius can't be reduced to 10%. Nonsense. I've done it faster and with bigger radius reduction. This is and that's a typical setup that I'm calculating there. If you look at any of them, that's how they run. Okay.
Yeah, but no, what I'm asking for specifically is, what do you mean by optimizing radius reduction?
I mean, I've performed the ball on a string and made the ratio of the radius reduction much higher than 10%.
The ratio of the radius reduction.
It's all irrelevant anyway. This is irrelevant. I'm just saying that I've performed this experiment in a manner that it should be much faster than this is.
What's happening faster? What quantity is occurring faster here?
What are you talking about? Okay, what I'm saying is that this demonstration of 2 revolutions per second with the radius reduced to 10% of original is a very reasonable version of the demo.
Okay, here, Michael, I'm gonna share my screen just so we're all on the same page here. Here's.
Okay, and my personally be performing it much faster, whatever is actually just irrelevant to the point.
So
I'm not evaluating what I performed. I'm evaluating the one that I've specified.
Just so we're all on the same page. But what I mean by questions about optimization, let's say you have some specific coin. Let's say the length of a rope that connects.
Sorry, Jack. Can I just lead you away from this nonsensical discussion about optimization? Because it's nothing to do with the argument.
We've already strayed away from it. So, Michael, if you want to do the mute thing, whenever John is speaking, go ahead and mute me. I noticed you didn't do that, but for now, could you just mute him so I can get my point across without interruptions? And
this is to be the open discussion part. So, John and Jack, both just make sure that you give time so that I hopefully don't have to come in and interrupt. So, John, just let Jack do what he's talking about here, and then you can have a response. Okay.
Okay.
All right. So if you have some curve defined over some domain, and let's say you specifically want the minimum value of okay, let's call this f of x. Why not? The minimum value of f of x over some interval a b. So here I'll even draw my axis in a b. When we say we want to optimize this, then we would say at what point, for what f of x naught is equal to m, where m is less than or equal to f of x, for all x within that particular interval. So that's why I'm asking you, what do you mean by optimize? Because so far you're just saying you perform an experiment, but you haven't told me what you're trying to optimize. You're trying to find the maximum value, so I'm trying to minimize something. Optimization means something when we're doing applied mathematics. But
the optimization doesn't apply to my maths. Well, the only reason I said that is because I have run this experiment with much more extreme values.
Okay, that's
so
not
those values that I've chosen.
We'll move on from that. All right. Now I saw someone in the comments asking, why do we have the ratio of the radius? Okay, so here let's write this down. Okay, so L. We're just gonna stick with the magnitude of the angular momentum for now. So L, we'll just say that usually L we denote it with the arrow above because it's a vector quantity. We're gonna say that L without the arrow is equal to the magnitude of the angular radius or the angular momentum, and L is going to be equal to I times omega, where I is the moment of inertia and what's called omega is the angular velocity. Now, the reason we have a ratio of radii is because I, for basically a spinning object, or a spinning ball rather, is going to be equal to the mass times the radius squared. So if we want to show that angular momentum is conserved, in other words, L1 is equal to L2, then I1 omega 1 is equal to I2 omega 2. Now we can further, based on the definition of I, we can say that M1 R1 squared omega 1 is equal to M1 R2 squared omega 2. We divide by M1 on both sides. That leaves us with R1 squared omega 1 is equal to R2 squared omega 2. I'm just drawing W's for crying out loud. And from here, if you want to show the ratio of the, or actually, if you just want to show what the final angular momentum will be, or the angular velocity will be, omega 2 is equal to omega 1 is omega times R1 over R2 squared.
So you've presented my equation one.
I'm just explaining what this all means because someone in the
Okay.
comments in the live chat was asking.
I see. Okay, all right, no problem.
Right, but just that preamble aside, so far I don't see anything that's contentious.
Mm-hmm. Okay, so you agree then that W2 is 12,000 RPM. That's the correct prediction of physics.
Yeah. Let's see. Just your value is, we start off with 2 revolutions per second. Okay, that's actually input that now. Okay, I'll share my screen again. Where's my thing? All right. So we say that omega 1 is equal to, what was it? 2 revolutions per second. That's 4 pi radians per second. It's equal to 4 pi. What was your initial radius? Okay, just some arbitrary radius, okay? And we're going to define R2 as being 1/10 of that.
Yeah.
So R2 is equal to 1 over 10 R1. So then omega 2 is equal to R1 divided by R2. That's equal to R1 divided by 1 over 10 R1. R1. The R1s cancel out. That gives us omega 2 is equal to 10 squared. That's 100. 100 times omega 1. So omega 2 is equal to 400 pi radians per second.
Sorry, if W1 is 100 W, or W2 is 100 W1, W1 is 4 pi. Okay, 400 pi. Yeah, all right.
Okay. Now, is that here? If we want to figure out revolutions per, what is it, per minute?
Yeah.
All right. So first we have it in radians per second. So let's convert that to angles in terms of degrees. So that's multiplied by 180 over pi. So 400 pi times 180 over pi, just to get the unit conversion down. And then we want to have this per minute. So then we multiply by 60. And so pi cancels out, 400 times 180 times 60. I'm doing mental math right now. 400 times 180. I think I had what's it called? No, wait, that's in degrees per minute. Shit, that's not right. We want 400 pi by 60 to get into pi radians per minute. And then we divide by 2 pi. That's it. So yeah, pi cancels out. That's 2400. 24,000. Divided by 2, that's 12,000.
Okay. So we agreed.
Yeah, I'm fine with that.
We agreed that physics predicts that it'll accelerate like a Ferrari engine. Okay. Now,
Assuming there's
no torque, right? Sorry?
Assuming there's no unbalanced torque acting on it, yes.
Okay. Now I'm talking to engineers, right? So I don't have to get into a big, deep argument about whether 12,000 RPM is a reasonable, useful prediction for that experiment. It's not. Which means that the theory is wrong.
That's not how that works, no.
That's exactly how it works.
So
If
why is it not?
If the results of experiment do not match the predictions of theory, then the theory is wrong.
No, because you have any sort of
That's Richard Feynman's
external unbalanced torque. If you were to actually perform this experiment, you're going to have to deal with experimental error from things like air drag or friction. These are things that you need to.
We discussed friction in my introduction. Okay, friction is a joke. It's a joke. It's a joke. Listen to me. Let me talk now. It's a joke to tell me that friction can cause the loss of a Ferrari engine to energy. This is nonsense.
Okay, explain why it's ridiculous.
It's absolutely ridiculous because a Ferrari engine, where if you're going to stop that with your bare hands on the crankshaft, you're going to burn your fingers. The professor would burn his fingers. Your friction is going to magic heat.
Of a Ferrari engine, though, you're trying to accelerate it up to that point, but because there's always going to be some torque acting on it, you're never going to get it that high.
Okay, all right. So let's assume that you're right. Okay, so we assume that you're right. That means that the professor must put the energy in, right? Because angular momentum is conserved, so the professor must yank that energy into the system, right? In the first place. Otherwise, it can't be lost to friction. You know, if he doesn't put that energy in, then angular momentum is not conserved, right? Okay, do you agree with that?
If you're gonna change the energy within that's intrinsic to the rotation of the object, then yes, you need to input some amount of energy.
So the experimenter must put this in. Okay, so you're saying that if there was no friction, an ideal setup, whatever, then it would accelerate like a Ferrari engine. So in order to prevent the energy required to do that comes from the professor pulling the string, right? Physics doesn't give us the option to reduce the radius using less energy if we're not strong enough, for example. Okay, physics says if we want to reduce the radius by that much, we have to put in sufficient energy to conserve angular momentum. If you're trying to claim that we can reduce the radius using less energy than is required to conserve angular momentum, then you're agreeing that angular momentum is not conserved. And is that right?
Angular momentum is not conserved when there is an external unbalanced torque acting on the system. If you need to supply some torque of your own in order to get.
You're not answering the question. The question is that if your claim is right, the professor must put the energy in first before the unbalanced torque and friction can remove it.
To remove what? To accelerate up to that point? You're not increasing up to the RPM of
you're trying to claim that torque and unbalanced friction and whatever is going to cause the loss of the energy that we're supposed to see there. That's what you're telling me. And I'm telling you that if that's the case, then the professor must have put the energy in the first place. You've agreed with that, but now you're kind of umming and ahhing about it. Does the professor put the energy in? Where does the energy come from to conserve the angular momentum?
You have external torques acting on the object, which are removing some of its angular momentum, and then you need to supply some yourself in order to keep it.
No. But we're talking about the ball on string demonstration. The only input is the professor pulling on the string. If angular momentum is conserved, where does the energy come from for that conservation of angular momentum?
As long as there are no external torques, you don't need to supply energy to maintain angular momentum. You need to do work.
You do need to supply energy to maintain angular momentum because L equals R cross P. Did I not explain this to you? If you conserve the momentum and you change the radius, the angular momentum must change. Physicists say the angular momentum stays the same. So if they change the radius, the momentum must change. Therefore, you need extra energy.
You need to do work in order to reduce the radius. That much I'll give you.
You need to do work in order to reduce the radius. Okay, right. So you need to do work in order to reduce the radius. There is extra energy because if we're conserving angular momentum, like I've just shown you again, if we're conserving angular momentum and we reduce the radius, we have to increase the momentum. It increases magically without force or something apparently, but it increases. That's what physics says.
Yes, the linear momentum will increase.
Huh?
Yes, the linear
momentum will increase. Okay, so so that energy, the energy to increase the linear momentum must come from somewhere. Where does it come from?
It comes from you pulling on the string. It's really not
right. That's my point. That's what we're getting at. So in other words, in the energy, if angular momentum is conserved, then we cannot reduce the radius. We can't reduce the radius without putting in the energy required to conserve angular momentum. Otherwise, we're not conserving angular momentum. Do you agree with that?
Sure. If you're reducing the ratio, you're inputting energy. I'll give you that much. Move on. Keep going.
Okay, right. Move on. Right. So the professor's putting in the energy to conserve angular momentum to give us Formula One racing engine levels of energy in the ball on a string demonstration. Okay. And this is what your claim is. Okay, so if that is true,
never gonna get up to that point because there's always an external torque acting on it when you're trying to do this experiment. What part of this?
No, that's not the point. That's not the point that we're talking about. Okay, we're not talking about the external torque. The external torque you're talking. Can you let me talk? Can you let me speak?
I'll let you talk.
All right. You are claiming that this energy is going into the system because you're saying that angular momentum is conserved. If angular momentum is conserved, then the momentum is increasing, then the energy is going into the system. Can't be conserved otherwise. Okay? Right. Okay. That's what you're telling me. And this energy is being put in by the professor. So if that is true, then every single ball on a string demonstration of angular momentum ever conducted in history had the energy put into it by the Formula One engine levels of acceleration energy put into it by the professor. We're not talking Mickey Mouse energy here. We're talking a lot of energy to get a ball on a string to do 12,000 RPM. Okay, engineers know this. I shouldn't have to be pointing this out. Okay, right. Now, if the professor put that into the system, then every single demonstration ever conducted of a ball on a string must have been done by the Incredible Hulk, because it's not humanly possible.
Oh my
God. Yeah, that's right. Yeah, that's what it is.
I'm curious.
Yeah, your claims are incredulous.
Energy of a little ball, let's say 20 grams. Right. And that's speaking that from. Give me 1 second. I'm curious. What is the change in energy here? 1, 2.
While you do that, if I can, you can tune me out, Jack. While I do that, I've got two people have said something. We got Bella Charge said them figure skaters shouldn't be able to do that anyway. I get dizzy just watching them. People, John, so people were talking about figure skaters spinning beforehand. So
okay. And Steve figure skaters, yeah.
And then Bella Charge again says sounds like a cherry picking paper. So there's a little feedback from the audience there.
Okay, well, let's talk about ice skaters. Okay, ice skaters do spin faster when they pull their arms in, just like the ball on a string spins faster when you pull the radius in. But don't spin fast enough. If you work it out, you'll see. Don't spin fast enough. And if you look on my website at the measurements page, then you can see my measurement of Professor Walter Lewin. Okay, this is the best evidence that physics has, in my opinion. Walter Lewin's rendition of the professor on a turntable is got some special mechanism there. Is the friction-freest thing I've ever seen in my life. He turns there nicely on his little table there. The best demonstration available to physics. If I ask a physicist, produce your best evidence, he can't produce better than that. Okay, and you measure it, and it doesn't conserve angular momentum. The best evidence of physics has to offer doesn't conserve angular momentum. And you want to tell me that I'm cherry picking? Any bloody measurement you take, there's not a single measurement that does confirm conservation of angular momentum. Not a single one. No one can produce any counter evidence. When I say measurement, I'm talking about variable radii, okay? Because as we said before, if you're conserving the momentum and the angular momentum, and then you conserve the radius as well, then that's possible, okay? Variable radii system is not a single piece of counter evidence against. My evidence not good enough, though. You know, there's the standards are ever higher. You know, by the time I'll be doing a ball on a string demonstration, you know, at a in open space at a Lagrange point, and it still won't be good enough. But there's no counter evidence. So, you know.
So yeah, I don't want to be the one responding. I'll leave it to Jack. If you're ready, Jack,
Okay.
if you had something.
I just did the math just because I was curious. So for a a 20-gram ball starting off at 20 centimeter radius, then what we're gonna get is 2.27 joules. I'm sorry, yeah, I just it was 2 revolutions per second, I think it was. So 2 RPS, then that gives us 2.27 joules of energy, roughly. It's a little more than that. If we were to reduce the radius by a factor of 1/10, then we get 631 joules. So we increase the amount of energy that's intrinsic to the rotation of the object by roughly 300 times.
300 times. Okay, and you think that that's reasonable for the professor to pull the 300 times the energy of the spinning ball in the first place? It's nonsense. Okay, a 5-year-old could do a ball on a string demonstration. You don't need a incredible help.
Because it never spins that fast, because you have air drag, for crying out loud.
But if you are conserving angular momentum, then you have to put that energy in. You can't tell me that, oh, we're not sure, you know what I mean? We did it slower or whatever. So your energy has to come in. You can't tell me that angular momentum is conserved.
It's going out too, because there's an external force acting on the object.
I'm sorry, you can't tell me that we can. The law says, okay, let me talk. The law says that if we reduce the radius, the energy will increase because it's directly tied to the radius. Okay, directly tied. So we reduce the radius, the energy is going to increase. You can't tell me that we can reduce the radius without putting that energy in, because then you're agreeing that angular momentum is not conserved.
You're not getting the point. Oh my god! Here, I will do this one more time.
You are not getting the point.
Oh my god! I will. Hang on. You start off with some radius and some string connected to a ball that's moving around. That's an awful arrow. All right. Now, if you wanna, here, just so I can draw this. This is a top-down view. Let's propose top-down. Tab over top. Top-down. Side-on profile. It's basically going around. Here's the center. It's basically going around like that. And there's a string sits at the bottom, and you're going to pull down on the string in order to reduce the radius.
Yeah.
So let's keep it nice and simple for now. We apply some force. That is because basically the this point changes the direction of the force. So when we pull down here, we end up pulling in the radial direction here. So then therefore F cross R is going to be equal to 0. So there's no torque being supplied by you pulling down on the string.
Well, obviously it's a demonstration of conservation of angular momentum, so no torque is the first.
Stop. And because it's acting, or the force you're pulling on is going to go in the same direction as you're changing displacement, then what we get is just the magnitude of the force multiplied by the magnitude of the change in radius. That gives us the amount of work that we do. Now, as we continue to pull down, the amount by which we need to apply the force is going to change. Now, something else that you need to consider is air drag, because believe it or not, we live in what's called an atmosphere. There's a gas around us. So get this, right?
Listen, don't be condescending bullshit here with me, all right?
Stop it.
Okay, don't tell me there's a gas around us. Okay, that's
down.
Not acceptable. Okay, that's ad hominem.
Here's our radial vector. Now here, I'll just redraw this so that it's a little easier to work with here. There's a ball. It's going around in a big old circle.
You cannot accumulate enough air resistance to account for the loss.
All it needs to do is match the torque applied by, well, not the torque. All you need to do is match the change in energy being supplied.
How do you increase the angular energy if you can't apply torque? Because you just said you can't apply torque by pulling on the string, and you're right.
Angular momentum in a real-world experiment where you have an
How do you increase the energy, the angular energy?
So
How
we
do
have
you
a
increase
force
the
of drag.
momentum of the ball sideways? You're pulling down here, the
Perpendicular.
ball is there, you're pulling it towards you. How do you reach it?
There we go. Now he's piped down. We have a force of drag that's acting perpendicular to the to the radial vector. So the torque caused by drag, the magnitude of that is going to be given by the force of drag, the magnitude of it, multiplied by the magnitude of the radial vector. So all we need for E to remain constant, delta E be equal to 0, is the energy being supplied by you, which is this portion here, to match the force being, or the the work being done on the ball by drag. Now, angular momentum is not being conserved because when you're reducing the radius, that ball wants to spin faster, but there's an unbalanced torque. You're not supplying any torque because, as we just established, the force you're applying
How's the unbalanced torque?
parallel to the radial vector. So here, the torque caused by your applied force is going to be equal to the force that you apply cross.
All right, can I just stop you for a second? Okay.
Nope.
I just want to say something.
That is equal to 0. So why does the ball not spin up, or at the very least, it stops spinning up after some point? Because as it moves faster, or else it wants to move faster.
Jack, you are grasping at straws.
The torque.
Okay, you're not arguing my argument. You're not arguing my argument. You're presenting red herring. You're presenting red herring logical fallacy.
Yeah. Well, you know what? To a certain extent, I agree with you because you're working in an atmosphere where torque being caused by drag exists. You're trying to say that there does not exist some torque being applied by drag. That is ridiculous.
What is ridiculous?
That your argument is that because your prediction that does not account for an external torque does not match your experiment that does not
now let's talk about my prediction again, because where we're going to is here is you are now attacking equation 1. You're telling me that equation 1 doesn't include some external torque or friction or something. Am I right? You're telling me equation 1 doesn't.
Since you love to use pig Latin here, I'll go along with you. We'll do an absurd ad reductum here.
You're not addressing my
I'm going to prove to you by your standards of logic that linear momentum is not conserved, all right? So here, dp.
No, that's not acceptable.
dt,
That is a red herring argument that doesn't achieve anything.
Follow along.
You're not addressing my argument. You said you're going to address my argument.
Pool ball on a pool table. It starts off stationary, so its momentum is equal to 0. I hit it with
This is irrelevant.
No, it is relevant because it's the same stance.
No, it's irrelevant. Where's the rotation?
Pool cue. So P1 is equal to 0.
Where's the rotation? It's irrelevant.
P2?
We're discussing rotational motion. We're not discussing.
No, I've just disproven conservation of linear momentum. Except linear momentum, and just like angular momentum, is only conserved because of external force. Torque acting on the object. You can't say that conservation is violated because it's being acted upon by an unbalanced torque. That doesn't make sense. That's exactly what
I didn't say that. You're saying that.
No, that is exactly what you're saying there, pal. You're saying prediction.
I didn't say anything about unbalanced torque. You're putting words in my mouth.
Oh my God.
I didn't say anything about unbalanced torque, and you are not arguing my argument.
I did explain why your argument is wrong. I even used an analogy. You're not following along here.
What analogy? How is analogy of linear motion an analogy to rotational motion? That's nonsense.
Because
right. The reality is this. Okay, Jack. Can we get down to real basic simple terms here? Okay.
I've already done that.
The reality is this. Huh? Sorry? Can we do that? Yes or no?
Here, I will explain this in very simple terms for you, okay? Because you love simple
No,
terms.
I don't need it to explain in simple terms. I'm going to explain something to you. Is that possible? I'm trying to teach you something. Is that possible?
When the environment does not act on your system.
Look, you can't tell me that no experiment in
just
history. Wait, let me respond.
All right, Jack, let him respond.
Sure, let him respond.
Okay. You are trying to tell me that every experiment in history ever conducted is impossible because it's impossible to eliminate external torque or friction. It is not impossible to eliminate friction, therefore no experiment is valid. And this is what you're saying to me against my paper, because your own personal incredulity doesn't allow you to accept that physics predicts it's 12,000 RPM.
Physics predicts it's 12,000 RPM when there's an external force acting on the object.
No, physics predicts 12,000 RPM as per the equations from physics as I've calculated. That's what it predicts. Theoretical prediction, fine, but that's what it predicts.
Jack had to go. So did you?
Look, the guy is just evading the argument. He refuses to focus on the argument.
Did you include, John? I have a question. Did you include the resistance due to friction in your calculation?
No, because my calculation is based on the equations that I drew from physics, and physics does not include friction in there. And the reason physics does not include friction in there is because for 300 years, ball and string has been run for 300 years in open air using an ad hoc mass and a random thread by an old professor with wobbling hands in open air. It's been run like that. And this prediction is the prediction for that open air example. Fine, it's a theoretical prediction. We understand there is air resistance. We don't expect it to be perfect. So we wouldn't expect it to be 12,000 RPM. We'd expect it to be 10,000 RPM, maybe. Even 5,000 RPM, I'll accept. If you show me a ball and string doing 5,000 RPM, I'll accept that 12,000 is realistic. But what I see from a ball and string, 12,000 RPM is objectively wrong. Physics is wrong. If physics predicts 12,000 RPM for a ball and string, physics is making a wrong prediction. The whole point of physics is to make right predictions, and that's not useful. And the reality is that engineering equations would not predict 12,000 for this exact example. Engineering equations predict 1,200 RPM. And I know this because I've had engineers come and argue with me that my math is wrong and shown me the engineering equations. So engineering equations agree with me, and physics equations show ridiculous results.
Jack? Oh, Jack, I think you're muted.
All right. You said that physics does not include friction. That's just wrong. Physics does include friction. That's all there is to it. Drag and friction.
Did you hear what just went on? The engineering equations for this same example, the engineering equations predict 1,200 RPM. And I agree with. That's what happens in reality. Engineers have got the predictions right because they're conserving momentum. They've got it right. And physicists
angular momentum doesn't conserve.
Huh?
I thought your whole stick was that you're trying to disprove that angular momentum is conserved. Now you're saying it is?
No, I'm saying that momentum is conserved. The L equals RP, remember? The L equals R cross P. The momentum is conserved. And the angular momentum, because it is not conserved, because it is on the opposite side of the equation.
Yeah, I'm wondering what kind of formula the engineers use. They probably take into account things like drag and friction because they know how to work with real-world systems.
It doesn't matter. If friction is irrelevant, friction does not explain the difference between 12,000 RPM and 1,200 RPM.
They do.
If you would show me a ball on a string doing 5,000 RPM, then I'll accept it.
John, did you include in your paper?
I'm wrong, and you don't point out anything wrong.
John, did you include in your paper the engineering calculations?
No, I haven't. I just said
Oh.
I presented this paper. I just presented this paper, and the engineers have told me that I'm wrong and presented the engineering equations to me. And those equations produced a prediction of 1200 RPM for this exact same situation.
All right, so here, let's make this
Okay,
very simple.
the engineering equations go like something like R1W1 equals R2W2, something like that. Okay, no, that's how they're doing it. They are conserving momentum. And you can't tell me otherwise. That's what it is.
You claim that drag and friction cannot account for it. Do the calculation with drag and friction take into account and show how
No, I don't have to do anything. You have to do it because I've proven my point.
You're the one that
proof.
claim you're
This is a theoretical physics paper. That's a proof. That fulfills the burden of proof. Don't laugh at me, you prick.
I'm sorry, it's really hard not
The
to
burden of proof is fulfilled. Piss off.
This
Right.
dude.
You're going to lose me here. All
Watch
right.
your
This is
blood pressure
bullshit.
there, pal.
Don't laugh at me. You got nothing to laugh at. You have got the burden of disproof, and you are shitting yourself because you can't. Because you got nothing to say. Fucking bullshit here.
Oh my God. Move on to the other
All right,
page.
listen. This is not acceptable. Okay, you don't laugh here when you're wrong.
Oh,
You've lost the discussion.
I have not. I've told you that.
You
drag
have
and
lost the
friction
discussion.
take into account. You just like no, it doesn't. That's all your rebuttal is.
All the what, blah, blah, blah. All you got is blabber. You got nothing to say about the argument. All you can do is, friction, air resistance, this. It's just excuses.
Things that actually happen. Imagine that.
It's excuses, though, because it doesn't explain this discrepancy. You can't exploit friction to explain away a contradiction. We're not talking about a discrepancy of 10% or 20%, which is reasonable. We're talking about 12,000 RPM. That's what we're talking about.
Oh my God. I'm sorry. I'm reading this.
Oh my God. Oh my God. Any measurement you do confirms my work. Have you got a single measurement that doesn't confirm my work? Have you got a single measurement that confirms conservation of angular momentum?
Sure.
Have
Kepler's second law, because there is no
Kepler's
drag.
second law.
Negligible
Kepler's
drag.
second law. It confirms angular momentum.
Yeah.
Are
Kepler's
you sure about that?
angular momentum.
Okay. Oh well, I'm going to tell you another thing. Okay. Kepler's second law was developed by Kepler, obviously, who used the data from Tycho Brahe. Okay, and Tycho Brahe was the last of the eyeball astronomers. Again, the telescope was available, but he refused to use the telescope. He used his eyeball and a Flintstone sextant to look through at the stars. So Kepler used the least accurate data available to confirm his pet theory as a proof by geometric proof, which is nonsense in itself anyway. Okay, so what must I say? I can't tell you anything about that. All I know is that if Kepler's law is absolutely tied to angular momentum, as everyone believes, then Kepler's law is wrong. And I think Kepler's law is wrong. In fact, I know Kepler's law is wrong because the moon doesn't travel like physics believes.
What do you mean it doesn't travel like physics believes?
The moon does
that's
not.
new.
The moon does not accelerate and decelerate as it comes closer and further from the Earth. The moon has a constant velocity.
Show the.
I don't
show the data
think
for
that's.
that. I'd love to see a citation for
Can
that.
you show that?
There is a paper for that. The guys measured it, and what he's found is that the measurements only match the theory twice a month, like a broken clock.
All right, show the paper.
Can you find that?
Huh? Can I find it? Yeah, I can.
Do you know the guy's name? I could search for it too.
No, I don't remember everything offhand. I'll get it now though. Open velocity. There we go. I'll have it in a minute, I'm sure.
So Sifety K in the chat is saying that the telescope wasn't invented until 7 years after Brahe died.
Sorry, the what? Telescope was invented. That's wrong.
Says it was developed after Brahe died.
Wrong. It was available at his time. That was what. That's okay. Look, I'm not a historian and I don't have direct evidence, but I don't believe that. I believe that what I discovered is true. I don't think that's true. But anyway, it's not really relevant. The fact of the matter is he was eyeballing it with a Flintstone sextant. Okay, not accurate. Okay.
Yeah, but we've confirmed it all the way up to the modern era. That's like the flat Earth argument, saying that the gravitational.
It's nothing like the flat Earth argument, and I'm insulted by that. Okay.
Repeatedly.
Huh?
So the telescope was invented 1608. Brahe died 1601.
Okay, well then, Bra was dead before the telescope. Okay, great. So you've proven my argument wrong then, obviously.
Now I'm unfamiliar with the Flintstone sextant, but it sounds interesting. I do like their vitamins; they taste good.
All right. Okay, the measuring the moon. Yeah, we go. It's by. Crap. Okay, I don't know. I've got a link here. Can I send it? How should I do this?
You can share a screen.
You can send me the link by email, or you can do it in the side chat. Either way.
No, I'm on my phone here, and I'm on the computer. Yes.
Oh yeah, so on the computer, just send me an email. Did you get my email from earlier?
Yeah, I did. Yeah, I think.
You can just reply to that. I can bring that up and put it on the screen.
Actually, okay. No, I didn't get your email. Don't know why. All right. Okay. It's by Stephen Hughes, and the paper is called "Measuring the Orbital Period of the Moon Using a Digital Camera."
Stephen Hughes.
STEPH.
Measuring the apparent size of the moon with a digital camera?
No, measuring the orbital period of the moon.
Okay, hold on.
I can give you an Eric number. I don't know if that makes any sense.
There it is. Measuring the orbital period of the moon using a digital camera.
There we go. Yeah. So he specifies a way to measure the moon and whatever, and he doesn't actually say what the thing is, but he makes an excuse why it only matches the theory twice a month. And I'm sure that the reason he didn't say exactly why is because he wanted to publish. And if he would face the same crap I'm facing, he'll never get published.
What even is IOP? I'm curious. What's the journal? Institute of Physics for the Learned Society. Okay.
But anyway, the point is that you can measure the moon with a digital camera. I've been asking physicists for 3 years to present me measurements of the moon at perigee and apogee, and they refuse to present the measurements because the measurements confirm what I'm saying. The measurements confirm the moon's not going to speed up. How's the moon going to speed up sideways to the Earth when it comes close? There's no talk. You said so yourself.
Here, let's just go to the NASA data sheet. We can probably find.
The NASA data sheet is a lie. It is theoretical values. It is. It's theoretical values. Listen, I'm contesting that, and I'm telling you those are theoretical values. You can't tell me they're not theoretical values because they are theoretical values. There's no measurements of the moon's velocity. Those are theoretical values. The scientists imagine that it speeds up and slows down, but in reality, it doesn't do it. Just
and
like they imagine
an orbiter on the moon.
Huh? I'm sorry, you can't present me theoretical values and tell me that's data. That's bullshit.
We do have that here. Yeah.
And I know that theoretical values because I've had a discussion with physicists about it who went in depth and looked in and said, oh yeah, it is theoretical values. Okay, so it is.
Whatever it is, you showed them that.
So I have the PDF of the paper. Do you have a copy of the PDF, John?
Are you asking me?
Yes.
I've looked at it before, but I don't have it in front of me right now. So
Okay.
I don't know if I can get it. Let me see.
I can. It's okay. I can pull it up.
Anyway, look, I don't have it, but I know, and I'm really not. It's not really not that interesting to me. I'm not a moon scientist, and I'm not interested. Okay, but I know that you can measure the moon's velocity quite accurately, and I know that from this paper, because this is the paper I was asking people, measure the moon, and they said, oh no, whatever. There's the paper, you can measure it, but I didn't realize the paper had actually made the measurements. And then one of the scientists I was arguing with told me, but you see, he's measured and whatever, and it can only be measured twice a month to match the figures twice a month. Now, why is it only matched twice a month? Because the broken clock is right twice a day. That's why.
I have a feeling you're mischaracterizing his argument, but whatever.
I'm sorry, what was that?
I have a feeling you're mischaracterizing what he said, but sure.
Yeah, it's a bit much to cover right now. So I've put it in the chat so people can have a look for themselves.
Okay, that's great by me. Okay, but like I say, I'm not here to argue about the moon. That's not my thing. Okay. Okay.
So John, people are wondering, John, why you didn't include the engineering equations in your paper?
I'm not an engineer. I'm not a physicist. I'm an inventor. Right, but I've made a discovery. I'm obliged to tell people my discovery. I'm obliged to. It's not an optional extra. You discover something like this, you're obliged to tell people. So I made a paper. Then the mathematical paper I made only after 2 years of being told by physicists time and time again, maths is proof. You haven't proven it mathematically, then you haven't proven it. Maths is the language of physics. If you don't know maths, you can't do it. And if you can't prove it mathematically, you haven't proven it, blah, blah, blah. And I say, my logical papers are proof. They should be accepted, blah, blah, blah. No, maths are proof. They're not listening to my logic because they want maths. Then I give them maths. Now I give them the maths, and now it's now it's like Jack there. He's like, friction. It's impossibly optimistic to blurt friction and imagine that you shift the burden of proof.
Well,
you know what I mean? And now
saying it is too optimistic is a positive claim.
I don't know what you mean by that.
Well, if you say that
it's impossibly optimistic. It's like it's humanly impossible for an average person to do a normal ball on a string demonstration. Not with a 20 gram from 20 centimeter, with a 50 gram from 50 centimeter. Normal ball on a string demonstration is physically impossible for a human being to do that.
Yeah,
and 5-year-olds can do it.
And the point is that is a claim that you've said there, and right, that's the positive claim that you made, is that it's not possible, and but you didn't show in your paper where or why that's impossible.
Okay, because my paper is a reductio ad absurdum. I went into my physics book, and I'm a 30-year-old physics book from when I studied physics 30 years ago. And I looked in there and I said, what is the equation for the ball on a string demonstration? And I found where it showed the picture of the ball on a string demonstration and said, this is the equation for the ball on a string demonstration. So I take the equation out of my physics book. I say, physics says this is the equation. And I put that in my paper and I calculate it out. And I assume all of the assumptions that physics assumes. And my physics book obviously is assuming that friction is negligible and hand wobble is negligible and gravity is negligible. Otherwise, they would appear in the equation. So if you want to tell me that you're trying to tell me that my equation is wrong from physics, then you're not arguing with me, you're arguing with physics. If you're going to tell me the 300-year-old equation for the ball on a string demonstration, because it is 300-year-old demonstration, that is a 300-year-old equation, it hasn't changed in 300 years. If you're going to tell me that's wrong, then you're shifting the goalposts. I make proof that equation's wrong, and you tell me, that equation's wrong. Oh, thank you. You know what I'm saying? It's just like insanity here. That's what it is. It's insanity. You want to carry on in the paper? Shall we go to the next level?
Here, Michael, before we move on, I looked at the paper that he showed. I have it up on Sci-Hub right now. So they don't actually have any data on orbital velocity. What they have is a method of measuring orbital period. And so it doesn't actually prove what John thinks it proves here.
I never said it proved anything.
Then why'd you bring it up?
Because it only matches the theory twice a month. It does say that in there, right?
Twice a month.
Does it or not say that it matches the theory twice a month?
It does not.
Yeah, it does. Actually, it does. You're a liar.
Because I just controlled F twice and it's not showing up.
Right.
I'm
Well,
looking. There's no mention of only matching theory twice.
There is. Okay, if I have to bring up the paper myself, then I have to do that. Okay, let's do it. You know what I mean? But I mean, it's ridiculous that I'm having to do this. But the point is not this. The point is that the moon travels at constant velocity.
But that's not what the paper says.
That's not what the paper says. That's fine. That's not what the paper says. This paper shows that it's possible to measure it. Okay, I'm not a scientist.
Showing that it's possible to measure the orbital period, not the velocity. If you want to get really fine-tuned measurements with velocity, you're going to need to have better equipment than a camera. It's like flat.
I don't agree. You can measure it with a camera. You're wrong. Okay, you're wrong. You can measure it with a camera. You get photos taken 24 hours apart, and you can work it out. This is what the paper says here. All right.
As you can work out orbital period.
All right, look, yeah. Anyway, it's irrelevant, okay? Because I'm telling you, the moon doesn't travel. I know the moon doesn't travel like physics thinks it does, because the ball on a string doesn't travel like physics says it does. And the ball on a string, the physics is universal. So if the ball on a string does it, the moon does it. That's how I know it. Okay, I'm not a scientist. I'm not trying to be a scientist. I don't give a damn. But I'm telling you that if you measure the moon, it's going to be constant velocity. That's how it works, because the ball on a string does it. Science is universal. So measure it first before you laugh, because maybe you're going to be laughing at yourself.
No, I'm going to be laughing at you.
You're going to be laughing at yourself, okay? Because you measure it. Present measurements. Do you realize you have no measurements? You don't have a single variable radii measurement of an angular momentum conservation anywhere in history. Never been done.
Well, there's a positive claim. Here, let's look at data sheets for velocity of the moon, see if they actually match, because there shouldn't be any drag in, well, there should be negligible drag in space.
There's no data sheets for the velocity of the moon. Those are theoretical values.
Stop. When someone says that some formula is accurate, assuming that drag and friction are negligible, it assumes that you have an experimental setup where that is valid. That's like saying modeling the projectile motion with a parabola is only valid.
Look, this is ridiculous, and let me tell you why it's ridiculous. Do you know what the evidence is? Do you know what the evidence is of physics for conservation of angular momentum? What is the evidence of physics? What evidence does physics offer to teach students? What evidence do they offer? Shall I tell you what? One thing they offer, it spins faster. That's it.
When we reduce,
there's no measurements, there's no nothing. It spins faster. All right. The ice skater spins faster. The ball on a string spins faster. The professor on a turntable spins faster. The diver spins faster. Anything you want to look at, all of them all spin faster. And none of them spin fast enough. And that's physics can say it spins faster, and we must accept that. I can prove it's not spinning fast enough. That's not acceptable. I have to produce this higher level of evidence with extra measurements and do it in space at a Lagrange point before you'll accept my evidence. But spins faster, you'll accept. Spins faster is fine. No, you're laughing, but that's it. That's why you believe angular momentum is conserved. You believe angular momentum is conserved because you saw something spin faster.
I believe it's conserved because it's conserved.
You believe it's conserved because you saw something spin faster. That's it. That's all.
Unlike you, I understand how experimental error works.
No, don't tell me what I understand. You don't know shit about what I understand. Okay? That's ad hominem. That's not acceptable behavior. Okay. Fuck you with your laughter. Okay. You're laughing at me, but you're being stupid. You got no fucking measurements. Nothing. Not a single measurement. Show me one. And you laugh at me. I've made measurements. All my measurements confirm the angular momentum is not conserved. I've got loads of measurements. I've measured your best evidence. I've measured Professor Lewin on his turntable. It doesn't conserve angular momentum.
But you haven't taken.
That's your best evidence. Huh?
Yeah.
I think the thing that Jack's trying to say is that you have left out conflating variables.
I haven't left out anything. I've taken the predictions according to my physics book to say how you predict a ball on a string demonstration. That's what I've done. Don't tell me that's wrong. You can't tell me that's wrong to take an equation out of my physics book. Otherwise, what's the point?
Context.
Does the physics book also include air friction in your physics book?
The physics book does not include air friction. Otherwise, why would I do it? You're talking in circles here.
Yeah, because
I've taken the book, this equation out of my physics book for a ball on a string. It assumes that air friction is negligible. You can't tell me now that I must change, physics must change because I'm saying physics must change. Oh no, you're wrong. Physics mustn't change because physics must change. Doesn't make sense. It's irrational what you're saying.
Here, move on to the next page.
Yeah. All right. What page is that?
Yeah, we haven't settled the first page, but you can move on to the next page, okay?
I've already explained to you what's wrong, but you're not accepting it. So
you haven't explained to me what's wrong. You're making wishful thinking. You're making wishful thinking assumptions that blurting friction transfers the responsibility of proof. It doesn't. It doesn't transfer it. You haven't proved it by blurting friction. You can laugh as much as you like. Blurting friction does not disprove my paper.
You don't know what
blurting friction is irrational.
But I'm glad you admit that you're not a scientist, because I'd be frankly scared for whatever reason.
Listen, pissed off with your ad hominem attack. All right, that's not acceptable. Okay.
All right, next page.
So I'm on here. Page that starts with proof. Is that equation 10?
Yeah.
All right, I'll be muted. You go ahead and present your little shtick here.
Well, there's nothing to present. My paper's presented, so just go ahead.
All right. Yeah. Let me pull it up. Page 2, proof. E kinetic equals 1/2 mp squared. Blah, blah, blah.
Jack, maybe you can explain. The audience is going to want to have some explanation.
All right. Actually, here, what I can do is I can print this to OneNote, and then I can just write over the PDF. I think that'd be good.
This is the calculation of the energy increase for a ball on a string demonstration conducted, reducing the radius from 1 meter to 1 centimeter. And the result is 1,000,000% increase in energy.
Sorry, there's a lot of people in the chat asking about the abstract. We'll get to that.
And paper which makes a revolution has to be different. It can't be stock standard stuff. So my abstract is fine. It covers exactly what it needs to cover.
Okay there, bud.
I'm sorry, what?
I said okay there, bud.
No, don't take the piss out of me. I'm not your fucking condescension tool here. Fuck you. All right. Fuck off!
What
piece of shit!
Okay.
I'm gonna be gone if you laugh at me anymore.
Okay,
Fuck
okay.
you.
I'll
You've
stop.
got no reason to laugh. You haven't shown a single error in my work.
I've already
Fuck
done.
you. You haven't shown an error. You've made a fucking wishful thinking, grasping at straws, friction, blurting friction. That's not proving anything. That's bullshit. Okay, that's logical fallacy.
Sure there, bud. All right.
Yes, it is. Fuck you and your buddy. I'm not your buddy.
Let's come and run, buddy. Relax.
John,
No, I'm not going to relax. If a guy's going to laugh at me like that, it's not acceptable behavior. Okay? He's got nothing to say. All he can do is blurt friction. Doesn't accept that friction is not explaining it. All right, and laughing at me at the same time. It's idiotic. I'm dealing with a moron.
I'm reading
You're
chat.
a
I'm
moron.
reading chat.
Hey,
The people
hey.
in chat are fucking hilarious.
Hey, John.
Yeah.
There's a somebody a friend of mine has asked if he can come in. He's a just want to make sure it's okay with you. He is an engineer. I think he's got his master's. I'm not sure. He can explain that. He's asked if he could come in and ask a couple
anybody
things.
else that Jack idiot, because he's a blithering idiot right now.
Okay.
Yeah. See.
All right. Well, I sent it to AT2 Productions, so we'll let's see.
The guy can't even make a sentence together.
Too busy laughing.
Yeah, exactly. You're too busy laughing out of stupidity because you're being stupid laughing. The dumbass. To a ball on a string doesn't do 12,000 RPM. You think that's funny? Right. Moron.
Okay, there, bud.
No, don't tell me bud. I'm not your bud. Okay.
There.
Grow up.
All right. So first of all, we have what's called share screen. We have linear kinetic energy. That's wrong. It's
No, it's not wrong. It comes out of my physics book. It's not wrong. Okay, and you want to tell me it's wrong? Then how is it wrong? Because
it's angular kinetic energy, not linear.
Okay, angular kinetic energy equals half E equals half IW squared, right?
There you go.
Huh? Is that right? Huh?
Yes, that's the
Okay,
one.
and I equals mr squared, right?
Uh-huh.
Right, and W equals V over R, right?
Yes, you can reduce them to
Okay,
the.
so substitute it and you come out with half mv squared. So it's the right equation. So don't come with
Not
bullshit.
use it because it's just bad form.
It's not bad form because that equation comes out of my 30-year-old physics book. Will you let me talk?
Do not generalize it.
Shut up and let me talk. When you want to sit here and tell me you interrupt me every 5 minutes or what? That equation comes out of my 30-year-old physics book. So 30 years ago, that was acceptable. So don't tell me that you can tell me now that, oh, that's right, the equation is right. Okay.
Why don't you have interns make like this?
All right, so we have joined us is AT2 Productions.
Okay.
Good afternoon and evening, everyone.
Hi.
So, MC Toon started to give you a little bit of introduction, a little bit of background, and I will admit I have not caught the entirety of this because I actually, about 2 minutes ago, just stepped in the door from work. So,
Okay.
but while I was listening, a question had come to mind. And to give you a bit of background of my experience.
Right.
Associates in aeronautical engineering, bachelor's in electrical engineering, and I recently went back to school to pursue particle physics.
Excellent. Okay.
So my question to both of you, and John, this is towards you primarily, but also towards Jack a little bit. So John, you get the crack to answer this question first.
Okay.
When it comes to physics, what is the environment that they are dealing with when it comes to the predictions and the equations and the actual application?
I have no idea what you're talking about.
That speaks volumes. Jack, would you
No, it
take a
doesn't.
stab at it?
No,
Sure.
it doesn't speak volumes. Okay.
Yes, it
You are
does. Yes,
trying
it
to
does.
insinuate-
John,
No, it doesn't.
John, you have
Okay,
been
well,
very
well-
rude recently, and I would expect the same amount of respect to me that I have given to you so far. I asked Jack to provide his answer. Please allow Jack to answer.
Okay. Can you also understand that Jack has been very rude to me? You're telling me that I'm
It goes
rude.
both
I've been
ways.
rude under
It
both.
goes both ways. I am a new person giving you an opportunity. Don't ruin
All
it
right.
already.
Well, if you're going to start with ad hominem attack, then I'm not appreciating it.
How is he conducting ad hominem attack?
It is
Saying
an ad hominem attack. Telling me that speaks volumes is an ad hominem attack.
I will explain in a moment, and no, it doesn't.
Not said that, huh?
All right, let's go to Jack's answer
Jack?
here.
Okay, so whenever we're presenting some particular formula in physics, there is a specific context for when it's valid. So on this channel, we've discussed things like Newtonian and Einsteinian mechanics and when Newton's equations are not valid. Now, similarly, for conservation laws, they are only valid when a system is not interacting with its environment. So for example, let's move away from angular mechanics for now, and let's just give a completely separate example so we're all on the same page here, all right? I'm sorry, what was the name of the new guy again?
Jared.
Jared, are you fine with that? Me just presenting an analogy.
Yep. Well, it is, except here's the thing. I love the physics talks, and I know that's where your background predominantly is, but I will say you're nuking it. People in the chat have already got the answer that I was honing it down to the simplest explanation.
The simplest explanation is
Physics deals with ideal conditions. That's what it is. Ideal conditions. That's why they don't account for friction, why they don't account for minutia. They are looking at ideal, perfect, nothing messing with it at all conditions. Now that's where engineering comes in and starts putting those factors back into place. So you get your theoretical proposition and then your actual real world, which accounts for everything else, whether you like it or not.
Okay, now can I say something in kind of response to that? Okay. Engineering equations for this example that we're discussing, a ball on a string demonstration of conservation of angular momentum. Engineering equations they conserve the momentum. Okay. In the angular momentum equation, L equals R cross P, engineers conserve the momentum for a ball on a string demonstration. And that contradicts physicists who say the angular momentum is conserved because L equals R cross P. Momentum's on one side of the equation, angular momentum on the other side of the equation. If you change the radius, you either have to change the angular momentum or the momentum. Engineers are on some delusion that they conserve the momentum and the angular momentum is going to be conserved at the same time. They are deluded. That doesn't happen. It's not possible because it's on opposite sides of the equation.
I think you just turned yourself around there by saying that angular momentum was on both sides.
I never said that. I said that angular momentum, L equals R cross P. Angular momentum equals radius, cross product, momentum. Angular momentum on the left side of the equation, momentum is on the right side of the equation. Engineers conserve momentum using their real world equations, but they believe they're conserving angular momentum, but it's not possible because if you change the radius and you conserve the momentum, angular momentum has to change because it's on the other side of the equation. Does that make sense to you? Do you understand that?
You're confusing angular momentum with angular velocity.
No, I'm not. I've never said anything about angular velocity.
That's exactly it. No, right there. Right there is exactly the point. You have not said anything about angular velocity because that is what changes when you change the radius while maintaining the momentum.
Yes, when you change the radius while maintaining the momentum, the angular
velocity. You change the velocity. Yes, you were saying momentum and then angular momentum. You were using momentum twice.
Look,
that is why you are screwing yourself up. You are screwing yourself up on the terminology.
Stop trying to muddy the water and listen carefully to what I'm
trying
saying.
to freaking clarify it.
No, you're not. Because you're telling me you're not listening.
You are misusing the terms, which is screwing yourself up. You have admitted you're not a scientist. You have admitted you're not an engineer. You have admitted you're not a physicist. You have admitted to having next to no knowledge of all of these realms that you want to interact with.
Can you see me and stop your tirade of ad hominem and listen to me? And let me explain.
Repeating your words is not an ad hom, sir.
Sorry, what?
Repeating your words is not an ad hom.
repeating my words are not an ad hominem, but
Correct.
But telling
In
me
your
all
own
these
paper,
things about
you
me,
stated
telling me
you are not
that
these things.
Repeating my words is an ad hominem, actually.
No, it's
It
not.
is an ad hominem. If you're
No, it's
discussing
not.
me instead of, you're not going to. Okay, this isn't going to work because you're not letting me talk.
Fair play is a bitch, isn't it?
Are you going to let me talk?
Are you going to stop spouting bullshit?
So here, let me, if I could step in.
I've never done that, and that's ad hominem.
If I could step in for a second here, John, you've said multiple times that you're not a physicist, right?
That doesn't matter.
So if he says that you're not a physicist, then that's just what
but
you
he
said.
didn't say I'm not a physicist. Just said I don't know what I'm talking about. That's ad hominem.
No, that's just a statement of fact.
Yeah, I don't think that's
No.
ad
Here's
hominem.
Here's the thing.
Look,
I did not say that you did not know what you were talking about because you said
Is
that.
that possible?
I did not state that, sir. If you are going to quote me, please do so accurately.
Okay. Then what did you say?
I said that you have admitted to not being of these disciplines, and yet you want to speak about information directly related to these disciplines that you are getting wrong.
Okay, now let me tell you that to tell me that I'm not qualified to speak about something.
I did not say that, sir.
Can I finish my sentence? You just did say.
If you are going to quote me, do so accurately.
That's what you're saying.
You have stated you are not those things.
Right. And I've said that I'm not those things. That doesn't mean that I'm not qualified to speak about it.
Did I say you were unqualified?
To present my argument. Huh?
Did I say you were unqualified?
Sorry?
Did I say you were unqualified?
You did.
No, I did
You
not,
suggested
sir.
it.
No,
Okay,
I did
fine,
not,
you
sir.
didn't say it. Okay, can we move on from
Stating
this
you are
ad hominem
wrong
discussion?
is not saying you are unqualified. It is simply stating that you are wrong, as everyone has been able to see here today.
Okay, can you let me talk? Can I say something?
If you are going to try to quote me, I suggest you do so accurately.
All right.
All right, let's hear what John has to say here.
I'm trying to state my point. Can I do that?
Yeah, go ahead.
Thank you. Okay. Right. Angular momentum is L equals R cross P. That's the definition of angular momentum, the defining equation. All right?
Sure.
If we conserve the momentum, okay, and we change the radius, then the angular momentum changes because it's on the other side of the equation. You can't conserve the momentum, change the radius, and change the angular momentum. It's not possible.
So you can't.
Both,
you can't.
Again, the angular momentum is not what is changing. It's angular velocity.
Again, I'm not discussing that, and you trying to suggest that I'm not understanding something
because you're getting the terms wrong.
Else. Do you see angular velocity on the board here?
That is your problem. Huh? That is your problem.
No, the problem is you're not listening because what I'm trying to explain to you is written on the board here. And do you see angular velocity on the board? No. So what I'm trying to explain to you got nothing to do with angular velocity.
So because I write an equation wrong means I'm right.
I haven't written
That's your logic.
Wrong. Is this equation wrong? Are you telling me this equation is wrong?
I'm saying how you are characterizing it and how you are stating one of the terms is where you are going wrong.
Which term am I misstating?
You are saying angular momentum when you should be saying angular velocity.
No, I'm not, because angular velocity is not written on the board anywhere. So I'm saying angular momentum because angular momentum is written on the board.
God.
And thank you for going back to the point that I just made.
You said that I must say angular velocity, but I'm saying angular momentum because angular momentum is written on the board. What are you talking about? You're not listening to what I'm saying. I don't understand this. If I say angular momentum equals radius cross product momentum, do you agree that that's the definition of angular momentum?
I agree that you have a properly written equation there, but how you are defining that equation is wrong.
Okay, what have I defined that's
angular wrong? Velocity equals radius times momentum under.
Okay, now you've lost me. You're talking nonsense. You don't know what you're talking about. Angular momentum equals radius cross product momentum, not angular velocity. Seriously. So can I start again? And can we go through without interruption? Is that possible?
Yeah, go ahead.
All right. Angular momentum. It's angular momentum, not angular velocity, angular momentum, okay? Equals radius cross product momentum. That's the definition. That's how it's been defined originally. 300 years ago, that's what they said. Oh, there it is. Let's define angular momentum. What are we going to, it's radius cross product momentum. Okay. That's how it's defined. All right. This is the definition. In other words, angular momentum is defined as radius cross product momentum, right? It's defined to be dependent on the radius. This is actually proof already. Angular momentum is defined to change with the radius. Okay, but never mind that. The point I'm trying to make is that engineers conserve momentum. If you conserve momentum, and this is the definition of angular momentum, and you change the radius, then angular momentum on the other side of the equation, angular momentum must change. It's not possible.
And I have to actually say, I was incorrect with what you were writing there, and you are incorrect.
Okay, so you admit
I am looking at the equation right now with the actual definitions, and you are completely wrong.
Okay,
wait. You did get one thing right. You did get one detail right. L is angular momentum for the equation. However, the entire right side of it is wrong.
Okay, what is the right side of it then?
M times V times R. Mass times velocity times radius.
Okay, and what is mass times velocity?
Depends on the mass, depends on the velocity.
What is
These are individual variables. They are individual variables.
Fine. Then let's take it that way. Okay, let's take it your way. Okay, but no, it's not. Doesn't work like that. They're not individual.
Except it does.
The L equals mass. L. Are you telling me that angular momentum does not equal radius cross product momentum?
That is the correct definition for angular momentum, but the point is you're not taking into account things like external torques, and you're just, oh my god.
This is nothing to do with this particular discussion right now. Okay, what I'm discussing right now is that this equation is the correct equation. All right. If that is the correct equation, and engineers conserve momentum, all right, then when the radius changes, the angular momentum has to change because it's on the other side of the equation. It's not difficult, boys and girls. Not difficult. If angular momentum equals radius cross product momentum, then when you keep the momentum the same and you change the radius, the angular momentum must change because it's on the other side of the equation. Am I right?
Which angular momentum is angular velocity in this instance.
If I could just
are we losing our minds?
No, because here's the thing.
You are losing your mind.
Break it down to the actual variables. Break it down to the actual variables. What is P?
P is momentum.
What are the variables of P?
It's mass times velocity.
Okay, so write that instead.
Why?
This is where you're screwing it up. Write it down. Write it. Yes, it does. Write it down. Yes, it does. Write it down.
No, I'm not going to. You can't tell me how to conduct my own argument.
No, I'm trying to correct your argument.
Well, if it's wrong,
falsify my argument.
if it's wrong,
it's not wrong. That is the equation for angular momentum.
Your application is off.
Jack says it is.
You are confusing yourself because of what you are putting there. You are trying to keep the velocity constant. You are trying to keep the velocity constant.
I haven't said anything about the velocity. Velocity doesn't appear.
P is M times V, mass times velocity.
Right. I'm not trying to do anything with keeping the velocity constant. I'm telling you that engineers keep the velocity constant.
No, we don't.
Yes, you do.
No, we don't.
Yes, you do.
No,
He's
we
an
don't.
engineer. Why are you
You
asking?
conserve the momentum, therefore you keep the velocity constant.
No. We conserve in order to conserve the momentum and change the radius, you change the velocity.
I'm sorry, what?
In order to keep the momentum, in order to keep
In
the
V,
energy state equal, if you are changing R, you have to change V.
No,
What
you
is
don't.
V?
Okay, but
What
you
is
don't
V?
change V.
What is V?
Velocity. Listen, piss off with your
Thank
condescending
you.
bullshit.
Okay, here,
Okay,
let
fuck
me
you.
step in here. Let me get my
Okay.
Here.
Is this the equation for angular momentum? Yes or no?
Michael, okay, just for the sake of fairness, do you mind muting both Jared and John just so I can get this in without having to stop everything?
Yeah, I'll do that. There we go.
Okay.
John only is Jack is talking right now.
All right. So first of all, Clive Wells in the live chat just pointed something out, and I think this is just worth pointing out. Momentum in that equation is not actually being conserved in a object that's rotating about a string, because obviously momentum is a vector quantity, and because it's rotating, then therefore the vector is changing. So I think a more apt characterization would be what's called. If you want to say that the magnitude of the angular momentum is conserved, then we have to work with the magnitude of the radius and the what's called the linear momentum. Now, when he says that P is conserved, what he's really trying to say is that the magnitude of the linear momentum is conserved. Now, what he's not catching out on is that, let's say that for whatever reason, Jared, as an engineer, is working with some spinning system and he wants to conserve both L and P somehow. What that means is he needs to have the external environment act on the system that's rotating. You cannot have you cannot have the linear momentum be fixed, have R change, and also have L remain constant. But we see that in experiment because we have external forces and torques that are acting on our system. That is about as clear as I can make it. And that's really it.
All right, everybody's unmuted again.
Okay. All right. So, that equation is the angular momentum equation. Okay. The angular momentum equals radius times cross product momentum times momentum perpendicular momentum. Okay. All right. So, it's not possible to tell me that, oh, we can conserve the momentum and change the radius and apply some force and have the angular momentum conserved as well. It's not possible.
Well, I just explained.
Why are you wanting to ignore the velocity so hard?
Because the velocity has nothing to do with the discussion.
Yes, it does.
I don't agree.
Yeah, but
that's
the velocity...
why that is where you are wrong. You are trying to ignore factors that are inside of your own equation.
I'm not ignoring it. I'm not ignoring it. It's there. It's just inside.
Then why did you refuse to rewrite it like I had requested?
Because I'm trying to make a point, and rewriting it doesn't help me make the point.
Oh, it's almost like you have a bias and you're trying to stick with your head in the sand instead of listening with people who work with this on a regular basis.
Okay, you work with it on a regular basis. So now if I happen to do that with the L equals R in V, what would my point be then?
In order to maintain L when you are changing R, you have a subsequent change of V.
Okay, now but what I'm saying is that in with this equation,
that is what happens in reality.
Wait, let me say something, please. Okay, with this equation, okay, if what you're saying is correct, then it's the same thing. If you keep L conserved and you change R, then you must increase P. It's the same thing. You increase momentum or you increase the velocity. P is mv. If you increase V, you increase P. It's the same thing.
Again, do me the favor and rewrite it properly where it is RMV, please.
No, I won't, because that won't make any difference.
Please.
All right, I'm gonna do another one here. Right, I'll do another one here, and you see if you can make a point out of that. L equals RMV. Right, there you go. There's your equation. Okay. Now,
all right. Now,
engineers
no. You're my hand at this point. You're my hand, and I am going to use you effectively
to do what?
To maintain L.
To maintain L, yes.
Yep.
Right.
Yep. L
Yeah.
maintains.
Yeah.
Put a
Right.
down arrow below R.
Right.
And now M is staying constant because you're not changing the mass.
Right.
To
So
maintain
velocity goes up.
L, what must you do with V?
Must go up.
That is the conservation. As you increase or decrease the radius, the velocity must inversely follow.
Okay, now I understand that very well.
And that is
actually-
what
and
happens
can I
in
say-
reality.
Can I talk?
That is what happens in reality.
No, that's not what happens in reality.
Yes, it is.
That. I'm contesting that. That doesn't happen. And I can show you it doesn't happen. I've got proof of it.
Are you accounting
independent
for
experiments.
all factors that are taking place on the test weight?
I've got independent experiments. So the independent experiment, you can't.
So
tell
you
me
have
am
an
I accounting for.
you have an independent experiment using a
I have an
completely
independent experiment.
frictionless link with no friction
No.
or any
No.
factors on the way. Oh, so you don't have an experiment accounting for all the
I
factors.
do have an experiment. I have an experiment that doesn't account for factors.
And
of
that's
friction.
why you're
And
getting the errors. You are not
I'm
accounting
not
for
getting
everything
errors.
at
I'm
play.
getting a perfect confirmation. You can't tell me a perfect confirmation is an
You
error.
cannot
It's
get a
idiotic.
perfect analogy for perfect theoretical physics because you are not a
Listen.
sphere in a frictionless environment.
I agree with that, but my independent experiment confirms my prediction perfectly.
Except it does not match reality.
My prediction matches reality. That's what a perfect confirmation is.
No.
A perfect confirmation means a prediction matches
your
reality.
prediction is that angular velocity, angular momentum, and momentum is not maintained, is not conserved
momentum
throughout a
is maintained.
system. That
Momentum
is
is maintained.
wrong.
Momentum is maintained, angular momentum is not. That's what I'm being trying to say.
That is incorrect. Angular momentum is, velocity is not.
All right. If angular momentum is conserved, then why doesn't the ball on a string demonstration of conservation of angular momentum
Friction.
accelerate like a Ferrari engine?
Friction.
You can't say friction when faced with a Ferrari
You can
engine.
ignore it all you want. That is not going to change the answer.
You can ignore the reality of a prediction of 12,000 RPM as much as you want. That's not going to change the reality.
Yeah, Michael, you mind me getting in another word just because I was about to say this earlier.
Let's do that, and then I'm gonna.
Well, I need to go make dinner anyways. You two gents have fun. John, please go back to school.
You
It might
haven't
help
listened.
you.
You're an ignorant moron. So goodbye. and
I'm
good
the
luck.
ignorant
Okay.
moron, yet I'm the
Yes,
one
you
with
are.
multiple
You're the
engineering
ignorant moron.
degrees.
You
All
I'm
right,
back
all
in
right.
school for physics.
Jared, thanks for
Let
coming.
that sink in,
Argument
people.
irrelevant.
Let that sink in, people.
Thanks for
I've
coming,
actually
Jared.
done the work and completed something, yet I'm
Well,
the one
yeah.
who needs to learn.
Yes, you are the one who needs to learn because you have no evidence confirming.
Oh, shut up, you
conservation
wanker.
of momentum. You have no evidence
All right.
confirming
All
conservation
right,
of
Jared.
momentum.
See you, Toon.
All right, bye.
Later, Jack.
Right. Well, look,
Yeah,
how
but-
can you laugh? How can you laugh? How can you let the guy? He's got no evidence. Nothing. Nobody's produced a stitch of evidence in 5 years.
All right.
5 years. No one's produced evidence.
Jack has something he wanted to say.
Yeah, mute him just like we can do this like we agreed on.
All right.
All right. I'll share my screen. All right. So I was hoping to do this before Jared left, but I guess he can just come back and watch this later. So what he was talking about with experimental error. So let's give an analogy for another experiment that we could do. Let's throw a ball in the air and see how far it goes. Now, based on the way we formulate things like linear mechanics, so like we define acceleration as the rate of change of velocity with respect to time, and then from things like the magnitude, or actually let's just do gravity. Gravity is equal to g m1 over r squared, where m1, let's take that to be the mass of the Earth. Now, note that g is inversely proportional to the reciprocal of the square of the radius. And so if r changes by just a tiny little smidgen, then basically we can take g to almost be a constant, which is why you'll see g being a constant when you take things like with a terminal velocity. Now, so when we take into account things like gravity, the change in velocity with respect to time, as well as the angle at which we launch a ball, we get this equation: r is equal to v squared sine 2 theta g, where theta is just here. Let me draw that separately here. That's the horizontal. That's theta. It's the angle between the horizontal and the velocity at which we launch things. And so that gives us our theoretical value, and we can try and calculate what range that ball will land at if we were to go just by this alone. And we could get some distance r. Now, if we were to go out and try this in the real world, what we might get is a much smaller value. In fact, whereas the gravitational value that or the gravity-derived formula that we use here gives us a roughly parabolic arc, what we might see in the real world is something more akin to this, where basically it slows down at a rate that's proportional to the square of the radius. And so it ends up not going even half that far. Now, I cannot take this result and publish it in a physics or an engineering paper and tell people that I have just disproved gravity or linear mechanics. What I have shown is what's called experimental error, because we have drag involved. And that's something that affects the experiment, the outcome of the experiment. So what engineers do, and this is something I disagree with Jared on, he says that physicists only take a look at idealized solution. Physicists can in fact take into account drag, but what the difference between engineers and physicists is that, well, whereas like I'm a physics student, so I'm going to be trained to be a physicist. Whereas we emphasize on idealized solutions and then try to take into account experimental errors afterwards, engineers will try and make an empirical model that takes into account the experimental error just like basically right from the get-go. They work around experimental errors. Physicists just take it into account when we're doing experiments. Now, neither Jared nor myself could ever get by with a serious academic journal and tell people that we've disproven gravity or linear mechanics, because the distance the ball travels at is going to be different from what we predict from our value. Experimental error is a thing. Drag is very much so a thing. All you need to know about drag, like just for the audience, is that it's proportional to the square of the velocity for subsonic speeds. And so in other words, as something travels faster and faster, the force of drag increases rapidly. When we were to reduce the radius of that spinning ball because it increases in velocity, the force of drag also increases, and thus the torque it exhibits also increases dramatically. And I think John left.
John did leave, yes. So, if you can find your zen while I read a couple super chats, Jack. So yeah, he got a little worked up. Good job, Jared. Your soothing voice didn't soothe him enough. So and the George said for $5, John, show us on this doll where the ball on a string touched you. Also, Toon, you should shill my video at the end of the stream. And the George said has been shilling his own video. He has an excellent video talking about Vsauce and Nathan Oakley. So he's been posting that in the chat here, and if you do it again, I'll drop it into the description for you, Jordan. Let's see. General E. Shady for $2 Australians says, John, you're delusional. Get a grip. Wake up. Yes. Auntie. Oh, tell me if I get this right, man. Hervin Salo says, ask him what color tastes the best. He's not a flurf. So maybe that's not it. Bella Charge for 2 New Zealand says, you have a lot of beliefs for this paper. Just dismissing friction is a pretty strong belief. Bella Charge again says, John, when is this paper been published? When has it been published? You said it could be published in any journal with absolutely no problems. Well, of course, there's no errors. If there's no errors in it, do you know how you know there's no errors in it? Because he said there's no errors in it. Bella Charge says, serious question. What paper is better, this or SW? Sleeping Warriors. Oh my gosh, yeah. Well, this guy's paper is basically just a bunch of equations. His abstract is, oh my gosh, I can't believe his abstract. It was useless. And then Jess says, MC2 and ask him to say, let us introduce ourselves. I'm Hans and I'm Franz, and here we are here to pump you up. He left, so can't have him say it. Sorry. You got it from me. I apologize. So, all right, Jack.
All right. I did see a question earlier that I feel like should answer because, obviously not everyone is on the same page here. Someone asked, what is the difference between momentum and velocity? So velocity is just a rate of change of some object with respect to time, or the rate of change of some object's position with respect to time. And momentum is when we scale that velocity by the object's mass. And that's really all there is to it. Something else that I was going to mention, it's just off the tip of my tongue here. Oh, yes, I would like to present something that I found to be absolutely hilarious. It's the rejection of John's paper by all the mathematical physics journals that he submitted to. I feel like it's absolutely golden.
Sorry, I had myself muted when I said I'm going to pull that up, so let me... I pasted it in the chat a couple times, and yeah, it was... It is... I can't believe he actually, put it on his website for everybody to see.
Oh, no, here's the thing you need to understand, Michael. He brags about the fact that it gets rejected. When we're not talking about the validity of his paper, he likes to talk about how he got rejected by all these journals because he claims that this shows the prejudice of scientists. Yeah, I got nothing but that.
I mean, yeah, people are going to not just easily take something that contradicts centuries of science. Yeah. So anyway, so here we go. 2016. This was, so 4 years ago. We've reviewed your submission. Oh, apparently it used to be called And Now for Something Completely Different, which is a terrible title. And determined it's not appropriate for a publication in the American Journal of Physics. A manuscripts questioning well-established laws of physics are outside the purview of AJP and should be submitted to an archival research journal for consideration. Fair enough there.
So I think we should elaborate on that. What they mean by archival journal is we have something called ARXIV here. Now I should just post it in chat, ARXIV. And it's an open form that you can publish your paper in. And it serves two purposes. The first one is that you could always get someone to possibly critique it before you submit it to a proper journal. And another thing to take into account is that journals, they take a long time, especially the really prestigious ones like Nature and Science. They take a long time to review papers. And so this basically gives you a chance to get your research out there first while it's being peer reviewed, because who knows, maybe two people are working on the same thing at the same time and you want to be able to claim credit first. But the thing is that these archival forums, they're not peer reviewed. They accept just about anything. And so what I think the editor is saying here is that post this in a form with appropriate standards.
Yeah. Okay, let's see. Are there any in particular? Oh, here he changed the title to A Simple Proof That Conservation of Angular Momentum is a Fallacy. Not aware that fallacy is I wouldn't use that word, but fine.
Yeah.
Falsified, maybe. Here we go. He got a little better title here. Conservation of angular momentum regarding an orbiting object with a reducing radius is a fallacy. This is not a mathematical physics paper. Let's see. Again,
it was a professional grade paper. What he means by that is he has submitted this paper to editing companies. He's paid people to edit. Another person that has interaction with this guy, because I met him on Quora, another Quora user. This guy has spent several thousands of dollars trying to get his thing published, which I personally think is rather sad.
Oh my gosh.
Part of that money was spent, a couple thousand, I think. like the equivalent.
Yeah.
And part of that money was spent on editing companies who would edit the grammatical errors. He's conflated that to meaning that his paper is a proper scientific paper. So basically,
he has like 4 sentences in his whole paper.
I know. Oh,
Goodness.
Clive well spotted something. Control F and then search for poetry.
Okay. All right. I regret to inform you your manuscript, Ball on a String, suitable for do not find it suitable for publication in the Journal of Mathematical Physics. Personally, I'm a fan of poetry, but JMP is not the place to publish your verse.
Oh.
Also, I should point out that you're not the first person to go through a learning process before understanding angular momentum and the applicability of the associated conservation law correctly. I think that's it. Like, he refused to consider that friction played a part. This is the same guy. He keeps sending it to the same guy.
Oh.
To which I replied, well, if I'm not, then why is science still teaching fallacy? And it, of course, that the point is it's not. Oh my gosh.
Today, no response. Yeah, I wonder why.
Oh, here's a new title. If one defines the magnitude of a property to be momentum multiplied by radius, then one cannot reasonably expect said magnitude to be conserved when the radius changes. It's quite a catchy title there. A little catchier than, and now for something completely different. It's this. Oh, that's a different one here. Journal of Physics, a Mathematical and Theoretical. Is it? All right. Anyway. Yeah. Oh my
The quality
goodness.
of the presentation of any research published in the Journal of Mathematics or Journal of Physics, Mathematical and Theoretical, must be of the highest standard.
Yeah.
Yeah.
Well, yeah, and they go on and on and on. I mean, you know, he gets points for being, you know, persistent. I mean, you don't get a passing grade for being persistent. Wow. Nature physics. Did he try to publish in Nature? Is that Nature? When it says Nature physics, is that Nature?
Yeah, that's a subset of Nature.
Okay, so he tried to. Yeah. Okay. It is Nature physics policy to return a substantial proportion of manuscripts without sending them to referees. Decisions of this kind are made by the editors. While your findings may prove stimulating to others thinking about such questions, we regret we're unable to conclude the work provides a sort of firm advance in general understanding that would warrant publication in Nature Physics. So there you go. Well, did he try spirit science? Says Mandeville. You know, spirit science might be the place, John. Spirit science is definitely might be a better venue. Anyway,
about the abstract, and I just want to bring it up real fast. Where is my? There we go.
Yep. There's the abstract.
We're gonna scroll up. Oh, reductive atoms or canal. Okay, that's not how you write an abstract to a paper. The abstract is a summary of what you did in your paper. So, what did you set out to prove? How did you do it? What were the rough results? Like, how did you formulate those? How did you analyze it? And what were the conclusions? In a single page, I guess, set of paragraphs, you explain all of that. You don't write one. I don't even know if that technically counts as a sentence. A reductio ad absurdum catastrophe. That doesn't tell me anything. I would reject this paper on that basis alone if it were to come across my desk.
That's enough right there.
Some other red flags. Introduction. I am not an academic. I'd be done with it at that point. I'm not sure how much of a successful businessman this guy is if he's wasted several $1,000s trying to publish his nonsense.
Well, hey, if it puts money in the bank, I guess he's a successful businessman, right? But yeah, it's saying I'm not an academic and saying I'm not a scientist doesn't mean that you don't have to have the same rigor.
Yeah.
So
He also didn't know what an ad hominem is. It's where you make an argument that's the premise is on some character of your opponent. Like if I were debating you and I said you're wrong because you have short hair, that would be an ad hominem. Me saying, I don't know, you're a software engineer, so you don't know anything about biology. That's not an ad hom. That's just a statement of fact.
yeah. Well, I think we can get moving here. I do have a stream later tonight in 3 hours with Avery Walters, Flat Earther, from Facebook. I've got might have something on Thursday afternoon, which would be 4 o'clock Central Time. I'm trying to put something together for that. So yeah, so somebody was asking, is there's another debate. I think I saw that Team Skeptic had something at 6:30 Central Time. So be sure to check him out for just an hour and a half, no more than an hour and a half, because then come back here. Anyway, thank you for finding this worthy opponent, Jack.
Yeah. I did say I was gonna retire from Flat Earth for a while because at this point we've gone over everything that needs. We're just repeating ourselves, so I figured we change things up a bit.
It was 2,000 years ago, kind of settled. Anyway, yes, but it's entertaining. So, all right. Well, thank you for everybody in the chat. Thank you for super chats and channel members and patrons. I updated my outro here to have the updated channel members and patrons. So if you like this and you think more like this is something you'd like, let me know about that. I'd be interested to see if that's the kind of thing versus just Flat Earth. Of course, I do 5G stuff too, so kind of both of those. Anyway, we'll see you all later tonight, everybody. Have a good day.
See you later.